everyone. Myself Prayak Patel, working as assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the counting sort algorithm. We already discussed the sum sorting algorithms. Now last sorting algorithm consider as a counting sort algorithm. Now first consider one example for understanding of the counting sort technique. So sort the following elements in ascending order using the counting sort algorithm. Here consider the given data is like 3, 6, 4, 1, 3, 4, 1, 4, 2. Now first understand how counting sort algorithm will applicable. So here consider the given data in form of repeated element are there, or consider the range of the data is limited. So here in this example we have considered as an element like 1 to 6. Only your range is from 1 to 6 and some data are repeated elements. So that's why we can apply the counting sort algorithm. So counting sort algorithm can be applicable on the data like the repeated element and range of the data is limited. Now consider the step number 1. In step number 1, given element are stored in array or input array A of 1 to 9. So here consider total 9 element are there. So array A from 1 to 9 consider as a input array. So index of the given array is from 1 to 9 and element of the given array is like 3, 6, 4, 1, 3, 4, 1, 4, 2. Now step number 2. In step number 2, consider the one array number C, array name C. Now define a temporary array C. The size of the array C is equal to the maximum element in array A. So here consider the array A. In array A, find the maximum value in array A. So here consider the maximum value in given array A as a value 6. So consider size of the array C as a initially considered array C from 1 to 6. So C of 1, C of 2 up to C of 6. And initially C of 1 to 6 set to 0. So here consider the array C index from 1 to 6 and element of the array number C as a value 0 for initially all the element considered as a 0. Now why we use the array C? Array C store the element how many time of particular element is repeated. It's stored into the array C. So array C used for store the frequency count how many time particular element will be repeated is stored into the array C. So consider the step number 3. Update array C with the occurrence of the each value of array A. So here consider the array C value as a location 1, consider value as a 2 because 1 in given array A, 1 repeated 2 times. So we can say that at index 1 we can put the value as a 2. Now for index number 2 in array C, how many time 2 number of element is repeated? So 2 occurs only one time in array A. So here consider the value as a 1. So according to that you can consider 1 2 time, then put value 2 into the column 1, then 2 repeated 1 time, so put 1, then 3 repeated 2 times, so put 2 in column 3, then 4 repeated 3 times, so put 3 in column number 4, 5 not available, that's why put 0 in column 5, and 6 occurs one time, so consider column number 6 value equal to 1. So array C is here. Now update this array C. In step number 4, in array C from index 2 to end, add the value with the previous element. So for the index number 1, no any change for the index number 1 in array C, but from the index number 2 to index number 6, you can add the previous element with the current element and update the value of array C. So here consider the array C and update this array. Now here first initially column number 1 value 2 as it is because our index from 2 to n. Now for the index number 2, what is the value? So initially put the 2 at location 1. Now for the index number 2, you can consider the current value of index 2 as a 1 and previous block value as a 2. So 2 plus 1 equal to 3. Now for the column number 3, in C of 3, consider as a C of 3 equal to, we can consider equation as a C of 3 equal to C of 3 plus C of 2. So here consider the previous value as a 3 plus current value as a 2. So 3 plus 2 equal to 5. Now consider the next index as a 4. C of 4. In C of 4, consider the previous updated value as a C of 3. And C of 3 value as a 5 plus 3 equal to 8. Then 8 plus 0 equal to 8. Then 8 plus 1 equal to 9. So according to this, you can update the array C with the previous value and current value addition. So this is your updated array C. In this array, we find the how many time particular element is repeated, and we can find the last index of your array. Now consider the next as a create an output array B from 1 to 9, because we have a total 9 element. That's why our third array as a output array B. We have a 3 array. First given array as a array A, then second array is array C, then third array is resultant array as a array B from 1 to 9. Start the post the element or put the element into the array A to array B in given sequence. So here consider the input array as a array A. Now consider the element as a 3, 6, 4, 1, 3, 4, 1, 4, 2 is given array. Now from the last position to first position, you can apply the operation or perform the operation and put the value from array A to array B using the array C. So temporary array C, we have one array C, updated array C. Now consider the output array B. Now how we can put the value into the array B from the array A? That's why here consider the equation. Now here last value, block number 9 or column number 9. In column number 9 we have a value 2. So consider the column number 2 in array C. So here in column number 2 value consider as a 3. Now here value is a 3 in array C. So consider the location 3 in array B and put the your A of I value into the B of J value. So here A of I value means 2, A of 9 value as a 2, and put the value 2 in your location B of 3. So here simply we can say that from the array A we start the process from last location, consider the particular value, then this value become an index of the array C, then value of the array C become an index of the array of B, like this. Now consider the previous location as a location 8. But before considering the previous location, you can update the array C, because we already have a value 3 at C of 2 location, but we put the one value at B of 3 location. That's why you can change the value or decrement the value in array C. So array C of 2 value equal to 3, but we update this value or decrement by 1 and consider the new value C of 2 equal to 2. So consider this 2 value as a updated value. Now for same process here, consider the location 8, value consider as a 4, then consider C of 4 location. Now in C of 4 location value equal to 8. So consider the 8th location in array B. So here 8 location, and now put the your value 4 in location number 8. Now after that decrement the C of 4, because old value of C of 4 equal to 8, but at the 8th location of B we put already one value. That's why we decrement the 8 by 1 and consider the new value as a 7 as a C of 4. Now next value as a of 1. In A of 1, A of 7. A of 7 value consider as a 1. So in C of 1 location consider the value as a 2. Now consider the array B location number 2, because here C of 1 equal to 2. So consider the location 2 and put the value 1 in location B of 2. So here value consider as a 1. Now decrement the C of 1. Then after decrement here C of 1 become the 1 from the 2. So new value as a 1 as a C of 1. Now next previous location consider as a location number A of 6. value consider as a 4. So consider fourth column of the C array, value consider as a 7. So here consider seventh location of the array B. In seventh location of array B, put the value 4. So here consider the value as a 4. Now decrement the C of 4 and new value of the C of 4 consider as a 6. Now after that consider the next location number 5, A of 5. In A of 5 consider the value as a 3. Consider location C of 3, value equal to 5. So in array B, put the value at location 5. So here location 5 and put the value as a 3. Now consider the next location as a of 4 and first we decrement C of 3 from 5 to 4. Now C of A of 4 location and value consider as a 1. So here consider the C of 1 and C of 1 value equal to old value equal to 1. So put the value 1 at location 1 and decrement the C of 1 equal to 0. Now consider next as a 4 value. So location number 4 in array C. Then consider the value as a 6. So sixth location, put the value 4 at location number 6 and decrement C of 4 from 6 to 5. Now value 6. So consider C of 6. C of 6 equal to 9. So put the value 6 at location 9 and decrement C of 6 as a 9 to 8. Now last value as a 3. So consider location number 3 in C array, value consider as a 4. So put the value 3 in location B of 4. So here value as a 3 and decrement C of 3. So here consider value as a 3 at location C of 3. So after performing the operation from last element to first element on array A, we have to find the resultant array as a array B, and array B consider as a sorted array or ascending order of the given data. So sorted array like B as a 1, 1, 2, 3, 3, 4, 4, 4 and 6. So this is considered as a counting sort result. Now final answer is this array B. Now consider the procedure for the counting sort. Counting sort, assume that each of the n input elements is an integer in range from 0 to k for some integer k. So here consider the k means highest number or largest number as a k, where k equal to big O of n. The counting sort runs for theta of n times. The complexity of counting sort algorithm is theta of n. The basic idea of counting sort is to determine for each input element x the number of elements less than x. This information can be used to place the element x directly into its position in the output array. Now consider the algorithm of the counting sort. First consider the input as a given array A, then output consider as a sorted array A. Now name of the algorithm counting sort. A 1 to n means given array A as a 1 to n, then B 1 to n means resultant array as a B 1 to n, and K means size of the array C consider as a K. In our previous example, K equal to 6 because our maximum element in a given array A equal to 6. So consider the K equal to 6. Now first for I equal to 1 to K2, C of I equal to 0 because we consider the array of the size C. So here consider the array C size equal to K. So here consider I from 1 to K. C of I equal to 0 means C of 1, C of 2 up to C of 6 equal to initially 0. Now J equal to 1 to N2. C of A of J equal to C of A of J plus 1. This loop will be executed for the find the particular element from the array A and count the how many time particular element are repeated. That's why we can use the C of A of J equal to C of A of J plus 1. Means read one by one element and update the array C according to how many time particular element or value is repeated. Now consider the third loop for I equal to 2 to K. Do here consider the update element or update the array C. So C of I equal to C of I plus C of I minus 1. Your particular location will be updated with your previous value. Previous value plus current value consider as a new value of C of I. Now last loop is for j equal to n down to 1 do, means you start the process from the last element and continue until the first element. What is the process? B of C of A of j equal to A of j, means your previous example we consider the value A of j and put the value A of j at the location. First consider A of j, then value of the A of j consider as a location for C, so C of A of j, then C of A of j value consider as an address or index of the array B, so B of C of A of j equal to A of j. So according to this equation you can put the value from array A to array B. So this is considered as a counting sort algorithm. And last step is C of A of j equal to C of A of j minus 1, means after putting the particular value in array B you can update the array C. So here consider the C of A of j equal to C of A of j minus 1. Now complexity of this algorithm, here consider the first loop from 1 to k, second loop j from 1 to n, third loop I from 2 to k, and last loop from n to 1. So here consider the first loop executed for k time, second loop executed for n time, this loop executed for k minus 1 time or k minus 2 time, and last loop executed for n time. So k value is less than n, that's why we can say that the maximum complexity of this algorithm is n, because here no any nested loop are there, each and every loop considered as an individual loop. So consider the complexity as a big O of n for the counting sort algorithm. In today's video lecture I will discuss about the counting sort algorithm and algorithm and analysis of the counting sort. Thank you for watching this video.